Now, out of this picture, we are going to do certain things. We are going to actually build an application. I'm not certain this is really a different color here. There seems to be one color on this board, and it's green. But we'll try here. This is supposed to be green, but this other one that's orange is supposed to be green too. So we're going to try this, but I'm going to make some marks here. We are going to actually do some stuff with an application server over here in Python using a package called Bottle. And Bottle and Python are going to allow us to interface to a set of databases that we're going to design. And I have already built the client, the set of code. All of this stuff is already built and already done. I will be giving that to you. And I already have test cases and examples. So one of the things we will do in this class is we will design the database to satisfy the needs of this existing client. And quite often you see in jobs that what they want is somebody that either has a knowledge of how this works or they want somebody to do all of it. Take a class in web technologies and web technology design if you want to get this stuff. Add that to your knowledge of database and you have a full stack engineering knowledge. And it doesn't matter which one of the different kind of front-end technologies you use. I'm using the minimum for this class because I want to keep it as simple as possible so you can see how this interaction works and what's going on. That doesn't mean that I necessarily use that on a regular basis. I'm very fond these days of GraphQL, although it has some disadvantages. And if you use something like .NET, it tends to hide a lot of the details, but when you get right down to it, when you get down to the bottom level, this is what's going on. And this is how it's accessing stuff. And when I talk about an endpoint, I'm talking about this is the endpoint for communication. That text, that name, that path, that is your communication endpoint. And that determines what you're going to do over here in the application server. So index.html is one endpoint. Logo.png would be another one, which might have a path in front of it. But each one of these URLs, these endpoints in communication, are what you're going to build stuff in here to work with. So you say, for this endpoint, this is how I'd like to have it happen. Now, as we're going through here, there are a number of different things that happen. One of those is called a method. Okay, and the methods are get, which is what it does when it fetches a page. It's asking for a request. Get is distinct because these pieces like Squid do caching on get. And there's a way to get around their caching, but that's how they work. Post, which is when you have a form and you enter it, is the next one. And most forms are handled via post, or you have to do something to the get method to get around the caching. Okay, you have to do cache bursting. Put, which is like an update in the database, and put also comes through with a method of pt. Okay, as often in REST systems tied to an update, and there is a delete method. But with those four methods and a particular path that we're going to work on, a particular communication endpoint, we can implement a complete database interface. And when we have one of those complete database interfaces with those methods and endpoints, we call that a RESTful system. There are some other criteria that people want to tack on to RESTful, like saying, well, these are verbs and things like that. I'm not fond of trying to assign to nice, clean database stuff English language grammar, which is really goofy. Okay, I'll give you an example of goofy here in a second. So let's just call this, it's a communication endpoint. They've got some methods. I map the methods onto database operations, and I'm done. And it doesn't matter what I call these things particularly. I want to call them something reasonable so that human beings can read it and understand it and know what's going on. But it's still just a title plus a method results in a particular piece of code running in the application server to get something done. So, the example of goofy English. I'll give you a sentence that I know is grammatically correct, and you will think it isn't when you hear it first. The old man the boat. And you go, this person can't speak. Well, man, in this context, is a verb. This means to get on board the boat and run the boat. And the old is a noun. So if you say the noun old, like old people, man, get on and run, the boat, it's grammatically correct. Man, is English just a crazy language or what? Like, what do you think? I mean, what is up with this word man? I mean, it has different places in the language. Sometimes it's a verb, sometimes it isn't. You know, it can be a noun, okay? It can be a pronoun in certain contexts. It can be an explicative. So when you start saying, well, this should be this kind of grammatical thing, nah, you better go back and check your English language first. And make certain that you actually understand that English is not all that well defined before you say, we should make the programming language more like English. No, we should make English more like the programming language is the reality. So that's kind of the things that go on. Now, up here in the client, when it gets back all these pieces, it renders it. It paints something. It puts a table on there. It puts on buttons that you can click. And when you click a button, what's really happening usually is that button is resulting in some piece of JavaScript running, which is then sending a message back and forth to down here at the database, to the application server. And those messages flow back and change what's on your screen. Now, that could be in the flavor of you clicked a menu and it painted a different piece of the application. It could be you entered some stuff on a form and you clicked submit and it sent some data through to create something. It could be you picked a row out of a table that you want to update and you click it and now it paints that row in a form so that you can update it. But in each one of these cases, what's happening is you're making this trip back and forth between these things. Okay, and I don't guarantee all the time that happens. I mean, maybe when it does a menu and paints a different section, it already has that up here. But most of these, when you're dealing with data, this is what's happening. Is this back and forth trip through all these pieces. Now, we can set up on your computer to run the application, the database. We probably are going to skip Nginx, okay? And we're going to skip the frame cloud and all these things because there is a special way to access your computer locally without all these pieces in between. And that is a thing called localhost. And that is 127.0.0.1 as an IP version 4 address. Or there is an IP version 6 address for this if you're on a Mac. But that means that your client can talk to a server on your system. And when we do this with your client talking to a server on your system, we're doing exactly what Electron does. So this is not an unusual thing. This is how I generally build desktop applications these days, is with stuff like this. And I'll give you examples of that, but this is how the picture works. And there are all these places in here where we have databases. Okay, sometimes there's ones right here that this is talking to do routing. Squid is running on top of a database. Routing tables are running on databases. Sometimes there's databases on clients. And most of them are SQL. Not all of them. But that's where we find the databases, underlying the architecture for lots of stuff. Okay. Last thing that I want to talk about here is what protocols are we using for some of these things before I erase all of this. Now, the protocols. This guy from here to here, okay, and back, is probably HTTP or HTTPS. The difference is HTTPS is encrypted with a transport layer security. So somewhere on your client, it encrypts it. Somewhere over here, it decrypts it. But you won't see much difference between these two, except in how they handle cookies. We're not doing web stuff that deep, so you won't see it. This is the one we're going to work with a lot. There is this other one, GQL, GraphQL. Okay, and it generally is running on top of WebSockets or WebSockets Secure, which is the encrypted version of WebSockets. WebSockets has the advantage of you can have something happen over here on the server and it can push a response out instead of the client having to drive everything. There's also some efficiency and time advantages and things like that. But GQL is another common protocol The other one that I'd like to mention is a thing developed by Google called protobufs. Protobufs are a high-efficiency, high-speed protocol that usually you see running over here if you have multiple servers. But there's nothing stopping you from running from your client using protocol buffers to communicate, and they would also be running on top of WebSockets. The other one that is really common to see these days is a thing called JSON RPC, which runs on top of HTTP and HTTPS. And JSON RPC basically says, I'm going to make a request, but instead of sending data in a form through, I'm going to send a request that has this set of JSON that is a call to some procedure in your application server down here. And it's going to respond and it's going to send JSON back. Now, when stuff gets sent back through this path, it has a format. You might have an image, that's in binary. There are different image formats. Cascading style sheets would be a particular format. JavaScript or JavaScript application format or JSON. Those are all different kinds of formats. And there are several hundred different kinds of formats that are commonly used in complex web clients like a browser. Most of the time in this class, when we send stuff back, we are going to send it back in JSON format. The exception to that is certainly the application pulls back HTML for the flat files and cascading style sheets and JavaScript and other stuff. But our application server is going to need to set that we're talking in JSON format most of the time. The other thing that gets sent back is they go out and they make an error. And you get back errors. There are standard error codes that come back, but we will put our messages in those error codes in JSON as well. So that's kind of the end-to-end of how we're going to deal with applications and where all the databases are hiding. You go to dial a phone number, and 307-721-2222, okay? Which is actually here in Colorado, it's a government operation. I use that one as an example. But there's switches in between. Switches are not as common these days as they used to be, but phone switches all have Oracle databases storing all the phone numbers to do all the lookups on them.